In section 6.4 today, percent of increase and decrease. Percent of increase and decrease. All right, the first thing you need to know is the formula. The formula is percent of change equals the amount of change divided by the original amount. We'll talk about what that means in just a minute. And just to shorten it up, all right, you can write AOC over ORG. We have to write the formula for the original problem for all of our problems, so we can use the shortened version. Okay, so percent of change is the amount of change over the original amount. What does that mean, the amount of change? Between the original amount and some new amount, how much are the quantities changing? All right, so you don't necessarily need to write the table or write the problem. Just look up here for a minute. Okay, there will be something that you write down. All right, and we're going to start with our original formula that the percent of change equals the amount of change between the original amount and the new amount divided by the original amount. Okay, and we are not worried about which value comes which in terms of, oh, is it positive or negative? We're just looking for the difference between the two values. From Saturday to Sunday, the number of hours that you spent online last weekend, from Saturday to Sunday. So on Saturday, we spent how many hours? 2. And on Sunday, we spent how many hours? 4.5. So again, it doesn't matter for the amount of change. We're just subtracting the values. So order doesn't necessarily play a part in this. I just need to find the difference between the two numbers, okay? So that's why I'm doing 4.5 minus 2 instead of the other way around, all right? And then I divide it by the original amount. Well, the problem gives me a hint as to what my starting point was, like which day was my starting point. And which day was that? Saturday. So I'm dividing it by Saturday's value, okay, because that was my original starting value. So 4.5 minus 2 is what? 2.5 divided by 2. So now that I have that simplified, I need to divide that. What's 2.5 divided by 2? Okay. Close. Should be 1.5. Oh, I'm sorry. Is it 1.25? Okay. 1.25. All right. But that's not a percentage. That's not a percentage. The percentage needs to be what? 125%. Yes, 125%. Okay? Now, I also need to recognize that from Saturday to Sunday, did my values increase or decrease? From Saturday to Sunday. It increased. Now, example 1 gives it away because it says finding percent of increase. Okay? But if it didn't, I can recognize that it's an increase because from my original amount to my new amount, my values increased. Okay? So on your quiz or your test, I'm not going to tell you if it's an increase or a decrease. How do you know? Well, from original to new, is it going up, increase, or is it going down, decrease? All right, let's look at the next two problems. All right, so instead of it being kind of wrapped up in a word problem, it straight up just tells you from 10 inches to 25 inches, from 57 people to 65 people. All right, so I'm going to use my formula. Percent of change equals AOC over ORG. Okay, amount of change. Again, it doesn't necessarily matter which one comes first. I'm just looking at the change between the original amount and the new amount. Okay, so I'm going to subtract. Does anybody think they know what I'm going to subtract? 25 minus 10. Just finding the difference between the two amounts. Now here's what you have to be careful of. You're dividing by the original amount.
Teachers, please pardon the interrupt.
So which one is the original amount? 10. That's my starting point. So I have 15 divided by 10, and now I change that over to a percentage. P equals 3 over 2, but then change it to a percentage.
1.5.
Now change it to a percentage. Yes. So it's 1.5, which is 150%. And if the example didn't tell us it was an increase, I can clearly see it's an increase because it's going from 10 up to 25. All right, and then you box it in as your answer. Okay, now I want you to try to set up the next one. Again, we're just going to keep writing this formula over and over again to help us remember it. I don't give you the formula on your quiz and test. You have to know the formula. Okay, the percent proportion, the equation, this formula for percent of increase. There's a couple formulas that you do have to have memorized. Okay, all right, so I want you to try to plug these values in, and then we'll keep solving it. AOC, did you do 65 minus 57?
Yes.
What did you divide it by?
57.
57, that was my starting point. So I have 8 over 57. Now, this is not going to work out to be even. I need to go out 4 decimal places. Go out 4 decimal places. Okay? 8 divided by 57. Yeah, I know. I know. What is it, guys?
Something crazy, man.
I know.
I
I know. 1403. That's all I care about. 1403. I know that it's a very long decimal, okay? So we're showing you one of these. It's right here in your book too, where the decimal extends far beyond 4 decimal places. But we only go out 4, okay? If it goes beyond that, we don't care. So we go out 4 to round to the 3rd decimal place. So does the 3 keep the 0 the same, or does it raise it up to a 1?
Keeps it the same.
Keeps it the same. So now the 3 drops off, okay? And I'm going to change this to a percentage.
14.
Very good. But now look, guys, it is approximate 14% because I know that it was a really crazy long decimal. It's very close to 14%, but it's not exactly 14%. So we must approximate our answer. You sure do. We could say increase as well. Sometimes it'll say find the percent of increase like in the directions and you know it's going to be an increase. But most of the time you do have to specify if it was an increase or a decrease. Okay, so that's a good point. It's always good for sure to write increase and we just read the directions and it should tell us as well. All right, so let's look at example 2. I need you to turn in your books to page 255. Turn in your books, please, to page 255. All right, on the chart on page 255, it gives us a percent of home runs, basically, or how many, should I say, how many home runs for each year in 2014, 15, 16, and 17. So the problem asks us, what was the percent of change in home runs from 2016 to 2017? So I'm still going to use my formula. As soon as I see percent of change, that hints to me or indicates to me that I'm going to use my formula. AOC over ORG, the amount of change, all right, between the 2 years. So from 2016 to 2017. So I just subtract them, all right? Again, I'm just trying to find the difference. So according to the chart, how many home runs in 2016? 28. And how many home runs in 17?
20.
Now, which value is my original amount?
28.
28, okay? So when we subtract, this looks awful familiar to example 1. 8 over 28, now here we go again. Okay? 8 over 28. We're going to change to a decimal. How many decimal places do we go out? 4. Point, what is it? 2857. So now what is our 4th digit doing to the 5? It rounds it up to a 6. Is the 7 a part of our answer? No, but because we had to round, now our percent of change is approximately 6%. Now, there you go. Is it an increase or a decrease? Well, it's decreased because in 2017 it was 16 it was 28, and then it goes down to 20. From original to new now, my home runs dropped. All right, 8 home runs, which is a 28.6% decrease. Decrease. All right, so we want to be specific. That's the percent of change. That it was a decrease.
Oh, because it was 21.
Yeah, because it went down from the original year to the new year. All right. Okay, so that's example 2. Last example, last slide, percent of error, okay, or the percent error. All right, so did you know that a lot of times when you're purchasing, let's say, hamburger meat or even like chicken nuggets or like a bag of chips or just a product that has maybe a quantity goldfish, okay? Do you think that they have, people in their factories that are looking at the goldfish bags and going, 1, a 2, a 3, and then they say how many per serving and they're multiplying it? No. How do they know how many goldfish to put in the bag? They're going by weight. They're going by weight. Well, with all of these manufacturing companies, there's what's called a percent of error. So they know basically what the quantity is that they're putting in each bag. You with me? Okay. So if you're the customer and you're buying, say, a pound of hamburger meat, and the person puts it on the scale and they weigh it, and you said you want to buy a pound and it weighs in at 1.1 pounds, they're like, oh, that's okay, it's close enough, and they just give it to you for the price of 1 pound. That's pretty good, right? You're like, yeah, I got like 0.1 of a pound for free. That's great. Margin of error. Okay, now stay with me. What if they put it on the scale and it's 0.9 pounds? They're like, oh, that's okay. You don't mind, right? I can still charge you for a pound. You're like, no. You put that other 0.1 pounds on there because I'm paying for it. So the margin of error is important. All right. If you own that company and you've got a really generous person on the scale saying, oh, that's okay, you're going to lose money. So that's what we call the percent error. We're trying to keep that error margin as narrow as possible. So here's the scenario. You fill bags. You work at a dog food plant. You might not want to tell a ton of people that. Okay, 16 ounces of homemade dog treats. That's my goal. Okay. The acceptable percent error when filling a bag is 5%. Tell whether the bag is acceptable. We need a formula, and this is very similar to the percent of increase and decrease. We're going to call it the percent error. We're going to abbreviate it PE. Percent error equals the amount of error. Okay, so basically how much you're off, because you're not exact. That's okay. Your employer knows that you're not going to be perfect. The amount of error divided by the actual amount. The actual amount. Okay, the amount that's supposed to be in there. All right, so that's my formula. So let's go down here and let's see if how much we actually put in these 2 bags is within the error margin. I know clearly that neither one of these values is exactly correct, right? 15 ounces and 16 ounces. If I'm the customer, I just got shorted and I'm not happy about it. 16.5 ounces, I'm kind of happy if I'm the customer, but is my boss going to say you put way too much in there and you're outside the margin of error? All right, so that's what we're trying to figure out. All right, so we're going to say PE, percent of error, equals, we need to find the difference between what was supposed to be in there and what's actually in there. Okay, I just need to subtract them. Subtract the values. Again, I'm not looking for a negative value here. I'm just subtracting them from each other. Okay, divided by how much is supposed to be in the bag. The actual amount. So what do I get? Yeah, 16. So I get 1 over 16. Now we need to see what that value is as a decimal. Well, technically as a percentage, but we'll get to a decimal first. What is that value? And again, we only need to go out 4 places. 0.0625. The 5 rounds the 2 to 3. Okay. All right. So, and then when I move my decimal to the right 2 places, This is approximately 6.3%. So am I within the acceptable amount or margin of error? No. All right, so I'm getting in trouble if I'm the one that bagged that dog treat bag, okay? So my answer is no, that I'm not within the acceptable error margin. All right, I want you to try to do bag B. We need to see, we know that they're off, but we don't know by how much. Are they within the margin, or do they need to redo the bag or find another job? Okay, all right, let's see. Okay, so percent of error equals, I have to subtract what I put in there versus what it's supposed to be and divide it by the actual amount of what it's supposed to be. I get half now divided by 16. And when I half it, what's my percent of error? 0.0312. Remember, I only have to go 4. The 2 keeps the 1 the same or raises it up? Keeps it the same. So this is going to be approximately 3.1%. Am I okay? Yes, I'm okay. I'm within the 5% error margin. All right. Got it? Okay, finding that percent error. And if you understand that, that's everything you need to know for section 6.4. And we've now completed the unit that will be quizzed over next week and tested over.